Right, so in our world of polynomials, we start with the power of 1, the straight line. Let's move to the power of 2, our quadratic. So the quadratic polynomial and the parabola. So some terminologies, some subtle differences. The quadratic polynomial, is that ax squared plus bx plus c? Notice there's no equals sign there. That's just a polynomial, ax squared plus bx plus c. The quadratic function is when we make it equal to, well in this case, y. So we now have a dependent variable and an independent variable. So that is the quadratic function. Well, if instead of making it y, we make it 0, or any other number for that matter really, we now have a quadratic equation, something that has to be solved. So it's a subtle difference between the three. If a is equal to 1, we call that monic. So that would be a monic quadratic. Coefficients, well, a, b and c, so they're the numbers in front of the algebra. Indeterminate. Indeterminate is another way of saying it's the independent variable. I mean, we can't determine what x is, that's what we're substituting in, and it tells us what y is. So sometimes called the indeterminate. Roots. They are the solutions to the quadratic equation. So you have roots of an equation. As opposed to zeros, they are the x-intercepts of the quadratic function. So the function has zeros, whereas the equation has roots. They are the same thing. And you will see people use the wrong term from time to time. So sometimes they'll say zeros when they should have said roots and things like that. Find the roots, because it's a quadratic equation I got there, of x squared minus 1 equals 0. The example is more for using the terminology of roots rather than, how do we solve that? But obviously we get x squared equals 1, so x is plus or minus 1. So therefore, the roots are minus 1 and 1. So graphing a quadratic. Well, we know that every quadratic function creates a parabola. The most basic of parabolas would be y equals x squared. So let's have a look at y equals ax squared plus bx plus c. Again, there are bits of information we can draw by just looking at the equation itself. A, well that tells us about the concavity of the parabola. So this one here is concave up, and it's when a is greater than 0. So when it's positive, that makes sense, because when you're positive, you're happy and you smile. And look at that, we got our lovely smile. So concave up, concave down. Down is when you're feeling down, you're upset, you're sad, you frown. So a is less than 0, that's concave down. So that's what a tells us straight away, which orientation is our parabola. Now b by itself doesn't tell us a heck of a lot, so let's jump to c. Just like any polynomial, the constant tells us the y-intercept. So c in this case is the y-intercept. The zeros, or the roots, depending on whether we're talking about the function or whether we're talking about the equation, they will be the x-intercepts. So we solve the equation to find the x-intercepts. Now let's look at b. By itself doesn't tell us a lot. In this form tells us a heck of a lot. Minus b on 2a is the axis of symmetry. So it tells us that center line. Now, you don't have to use minus b on 2a. If you've already found the zeros, because of the symmetry of a parabola, you just average them, because the axis of symmetry would have to be in the middle. Vertex, so the turning point, we know the x value is the axis of symmetry, always lies on the axis of symmetry, sub it into the function, and you'll get the y value. And if they ever ask you what's the minimum or maximum value of the function, they just want the y value, not the coordinates, because what they're saying is how high up does it go, or how far down does it go? What's the minimum value, the maximum value? So the y value. Let's do an example. X squared plus 8x plus 12. And no, I would not expect that you would write everything down I'm about to put up here. This is for illustration of the example, but these are what we're looking at when we see that equation. For instance, I wouldn't expect you to write that. A is equal to 1, it's greater than 0. Aha! I know I've got a concave up parabola. C is equal to 12. Well, I might plot that straight away. The y-intercept is 0, 12. There it is. The zeros, let's solve it. Now, you probably would do some working out here depending on the equation, I suppose. And what do we end up with? -6 and -2. So let's plot those, starting to take a bit of shape. The axis of symmetry, Again, I would not draw the axis of symmetry in. I'm only going to draw it in here, illustration for the example. So minus b on 2a, I get negative 4. Or of course, I could have averaged the x-intercepts there, and again, we get minus 4. So I know there's my centre point, there's my mirror, if you like. That's what's going to reflect either side. Vertex, sub the minus 4 in, and we get, by an amazing coincidence, also minus 4. Let's plot that. That's probably enough. We know it's concave up, it's got to go through those points, so there we go, there's our parabola. Lovely. What about they give me this sort of question? Find the quadratic that has roots 3 and 6. So basically they're telling us the answer of the quadratic equation. So I know it must be something like that straight away. Now how do I get it from those numbers? Because remember, if you were solving it, you would have said what multiplies together to give. So that last number must be 6 times 3 because they were our answers. The middle number is minus the sum. Why is it minus? Because remember, when you solve it, you would have ended up with x minus 3 equals 0, and x then became plus 3. So the sign changes. So it's minus what we get when we add them together. That's a much quicker way of writing it. Of course, you could have said, oh, well, I know it's going to be x minus 3, x minus 6, expand the whole thing out. I mean, that's going to work. But when you get one like this, where we're not talking about integer roots, we're talking about irrational roots, that's going to take longer to expand out. But if we know that pattern, I can go, well, that's all right. There's my answer. It's monic, so I know the coefficient of x squared is 1. I don't need that a out the front. But I know the product of the roots will be the difference of two squares, 7. That's the number at the end. In the middle, minus the sum of the roots. And the beautiful thing about adding conjugates, the surd disappears. So 3 and 3 is 6. Minus 6 is the middle term. This time they've given me a bit more information. The roots are 2 and 8, and the vertex is 5, 3. So they're not telling me it's monic this time. So this time I say, well, it's a multiple of. Well, 8 and 2 multiplied together give 6, adds together to give 10. It's a multiple of that, but now I know it goes through 5, 3. I can substitute that in. It'll give me an equation to work out a. So let's sub it in, and a is minus 1/3. So there is the equation of our quadratic. Question 4 there. Yes, use Desmos. Make life a lot easier for that question.